Imagine trying to seal a Ziploc bag. Like for you, it is a completely mindless task, right? You just pinch the corner, you align those little plastic tracks, and you slide your fingers across.
Right, you don't even look at it most of the time.
Exactly. But think about the sheer amount of physics your brain is processing in real time to make that happen.
Oh, it's a massive amount of calculation.
You're calculating the exact pressure needed to snap the track without completely crushing the plastic.
Yeah.
And you're adjusting for friction as your fingers slide. You're dynamically correcting your hand's path along a moving axis.
Which is incredibly complex when you break it down.
Because in the physical world, gravity and friction are just relentlessly unpredictable. And historically, this is exactly where artificial intelligence has just completely fallen apart.
It really has. AI hates gravity.
Right. We are so used to AI living in this pristine digital sandbox, generating text, painting pixels, writing code. But the second you step into the real world, that sandbox completely disappears.
Which is why the landscape feels fundamentally different this week. I mean, we are watching the industry attempt this massive, massive leap from digital generation to physical action.
Welcome to the AI Loop for Thursday, July 30, 2026. If you are joining us at the table today, our mission for this deep dive is to explore a huge structural shift happening across the tech industry. We are looking at the shift from implementation to orchestration.
It is the defining shift of the year, really.
Because as AI systems become capable of carrying out complex actions, the human role is changing drastically. So today, we're going to look at Google DeepMind's launch of Gemini Robotics 2, which is literally putting reasoning AI into the bodies of humanoids.
That's a wild one.
It really is. Then we will break down how a team used 64 AI agents to rewrite 500,000 lines of code in just 11 days.
Yep.
We'll uncover how standard benchmarks are actually hiding true AI capabilities. We'll dive into the brutal mathematics of formal verification. And finally, we're going to look at new economic data showing that your official job title is probably, already obsolete.
A lot of people are going to be surprised by that last
Oh, absolutely. So let's start with the physical world. Google DeepMind just announced Gemini Robotics 2. This is a suite of 3 models, and they are claiming this brings whole-body intelligence to robots.
Right.
So walk me through the actual mechanics here. Like, what makes this different from the robotic arms we see flipping burgers or, assembling cars on a factory line?
The crucial difference here is the VLA, or the Vision Language Action Model.
Okay.
See, in traditional robotics, you have this massive, clunky stack of separate systems. One system processes the camera feed.
Like the eyes.
Exactly. Then another system translates that into a spatial map. Then yet another calculates the inverse kinematics.
Which is what, exactly?
That's basically the math of how the robot's joints should actually bend to reach a coordinate. And finally, a control script executes the movement. It is just so rigid and brittle.
So if a coffee mug is like 2 inches to the left of where the script expects it to be?
The robot just crushes the mug or misses it entirely.
Yeah.
So Gemini Robotics 2 collapses all of that. The VLA model takes in the raw video feed and the human's text command, and it outputs low-level motor commands directly.
Wow, so it skips the middleman entirely. It just translates pixels directly into torque.
Precisely. It is a direct translation. And the dexterity is remarkable. They demonstrated this running on Apptronik's Apollo 2 humanoid using a 22 degree of freedom Sharpa-wave hand.
Wait, 22 degrees of freedom? That's not just a basic 2-prong claw.
No, not at all. It is manipulating individual fingers to tie knots and, as you mentioned earlier, seals Ziploc bags.
That is wild.
But the physical control is only half the equation here.
Right, there's a higher level system too.
Yeah. The other half is the high-level brain, which they are calling Gemini Robotics ER2, or Embodied Reasoning 2. This model tracks its own progress on a task in real time.
What does that mean in practice?
Well, DeepMind claims it can quantify a physical task, like, say, cleaning a kitchen counter. It can track it from 0 to 20% done, 40 to 60% done, with 57.4% accuracy.
Okay, I am struggling to wrap my head around how an AI actually calculates that. How does a neural network look at a messy kitchen and mathematically conclude, I am exactly 40% done wiping this counter?
It comes down to something called moment finding.
Moment finding.
Right, which ER2 achieves with 91.3% accuracy. Moment finding is basically a measure of temporal intelligence.
Temporal meaning time-based.
Exactly. The model is continuously evaluating the delta, the difference between the current video frame it's seeing and the semantic goal it was given.
Oh, I see.
It isn't just looking at the counter, it's predicting the sequence of visual states required to reach clean. It identifies the exact micro moments where a state change occurs.
So if it's, say, pouring coffee, it isn't just running a timer.
No, not at all. It's evaluating the fluid dynamics in the video fade with sub-second latency to identify the exact moment the cup is actually full.
It's like a human chef watching a batter thicken on the stove.
Right.
You're waiting for that exact second it coats the back of a spoon. You don't use a stopwatch for that.
Right, you use continuous visual feedback.
And you just know the moment when it happens.
And because ER2 has this continuous situational awareness, we're suddenly seeing multi-robot collaboration. DeepMind actually showed the Apollo humanoid and a duo robot working in a shared garage space.
Which is usually incredibly dangerous.
Extremely. Historically, if two robots got near each other, they would trigger safety sensors and freeze in these jarring stop-and-think pauses so they wouldn't collide.
Yeah, you see that in factories all the time.
But now, because ER2 can predict the other robot's trajectory in real time, they can seamlessly hand off tools to each other. They're relying on a new safety benchmark called Asimov's agentic.
Asimov, like the sci-fi author.
Exactly. It acts as a hard override to instantly halt operations if a human enters that predicted trajectory. They also released an on-device version of the model that adapts to entirely new robot bodies using fewer than 200 examples in just a few hours.
Okay, but I have to push back on this timeline a bit. I mean, it is incredibly impressive to see this in a controlled lab.
Yeah.
But the real world is infinitely chaotic. We're talking about varying lighting conditions, unpredictable floor friction, network latency. Is whole body autonomous control actually ready to scale, or are we just looking at a very expensive, highly curated tech demo?
Well, it is definitely curated, I'll give you that, but the underlying shift in architecture is very real. By moving to a continuous self-correcting loop, the AI isn't just following a script anymore.
Right.
It is dynamically reacting to failure. If a robot slips on a wet floor mid-stride, ER2 processes that unexpected visual and spatial delta and recalculates the motor output to regain balance before it falls.
Wow.
That real-time orchestration is the real breakthrough here.
Well, and if an AI system can successfully orchestrate physical actions in a chaotic, unpredictable environment like a kitchen, orchestrating purely digital systems in software engineering should be trivial by comparison.
You would think so, yeah.
And looking at our next topic, that is exactly what is happening. The engineering landscape is shifting so fast, it is hard to keep up. Let's look at what Jared Sumner, the creator of the Bun JavaScript runtime, just pulled off.
This is a wild story.
It is. He translated 535,496 lines of Zig code into Rust.
Yeah, and to give some context to anyone listening who doesn't write compilers for a living, that is a staggering undertaking.
Right. Zig and Rust are not just simple scripting languages.
No, they're both low-level programming languages, but they have fundamentally different paradigms, especially around how they manage computer memory. Rust uses a very strict system to guarantee memory safety, which prevents crashes and security vulnerabilities.
So it's not a direct one-to-one translation.
Not even close. Translating 500,000 lines of an intricate runtime environment between these languages manually would traditionally take a 3-person engineering team an entire year.
A year of grueling manual labor where you basically have to freeze all new feature development just to rewrite the foundation.
Yeah, exactly. It stalls the whole company.
But Sumner did it in 11 days.
11 days.
He spun up 64 parallel AI agents, utilizing models from Anthropic and OpenAI, and spent about $165,000 in API tokens.
Which is a fraction of the cost of that engineering team, by the way.
Absolutely. But here is the mechanical question I have. If I have 64 human developers working on the same code base simultaneously, they're going to step all over each other.
Oh, it'd be chaos.
Right. They will overwrite each other's work. It would be a complete Git conflict nightmare. How do 64 AI agents coordinate this without bringing the entire project to a grinding halt?
Well, they actually bypass traditional human workflows entirely. Normally, a developer uses Git work trees. They check out a branch of the code, make their changes in isolation, and then try to merge it back into the main project.
Right, and then you have to resolve all the conflict.
Exactly. But in Sumner's setup, the agentic system didn't use Git branches at all. Instead, they built a central orchestrator agent that mapped out the entire dependency graph of the software in its memory. So when a worker agent finished translating a specific module, the orchestrator analyzed how that change affected the rest of the code and managed the commits directly itself.
So the AI dynamically ordered the work based on dependencies rather than relying on human developers yelling across a Slack channel to coordinate merges.
Exactly. It's a totally different paradigm for collaboration.
That orchestration is wild, but it points to an even bigger shift here. Sumner noted that out of those 11 days, the AI agents only spent about 15% of their time actually writing the code.
Yeah, that's the most fascinating part of this whole thing. The remaining 85% of the time and compute was spent entirely on verification.
Verification.
Right. The agents were fixing compile errors, writing unit tests, and rigorously checking that the translated code functionally matched the original. And this mirrors a massive trend we are seeing across the industry.
Didn't OpenAI just release something about this?
They did. They released a report on scientific computing showing that academic researchers are adopting this exact same pattern. The human is no longer doing the math or typing the code.
So what are they doing?
The human directs the high-level architecture and sets the rigorous testing parameters, and the AI handles the implementation.
So the modern software engineer is no longer a bricklayer. You aren't laying the bricks or mixing the mortar. You are the building inspector.
That's a great way to put it.
You walk the site, you verify the load-bearing walls, you check the foundation. But this raises a terrifying question for me.
Oh, what is it?
If we are automatically merging over 100 pull requests a day based on an orchestrator agent's review, how do we actually trust code we haven't read?
Well, you build trust through automated hostility.
Automated hostility.
Yeah, you can't read 500,000 lines of code in 11 days, so Sumner relied on out-of-process testing, rigorous security scanning, and fuzz testing.
What is fuzz testing?
It's where you bombard the software with massive amounts of randomized, malformed data inputs to see if you can force it to crash. You aren't trusting the AI's code, you are trusting your testing apparatus.
Okay, but the effectiveness of that testing apparatus still relies heavily on the underlying reasoning capability of the AI model analyzing those results, right?
That's true.
And we assume these models are getting smarter because their scores keep going up on industry leaderboards. But looking at OpenAI's latest research, I'm starting to think our benchmarks are just lying to us.
They are definitely obscuring the truth, that's for sure. OpenAI just released a really fascinating postmortem on their testing with the ARC-AGI-3 benchmark.
Right. For background, if you're listening, ARC-AGI is a 2D puzzle game. It presents visual grid puzzles that require abstract reasoning to solve.
Exactly. And it is highly regarded because it tests a model's ability to learn unfamiliar logic on the fly. It prevents models from just memorizing the answers from their training data.
Right. And when OpenAI first tested their frontier model, GPT 5.6 Sol, against this benchmark, the model completely bombed. Like, it scored a 7.8%.
Which is terrible.
Yeah. For context, an average human scores around 48%. So this frontier model, which can write complex Rust code, looked functionally incompetent at solving basic geometric puzzles.
But the incompetence was an illusion created by the testing environment.
What do you mean?
Well, evaluations rarely measure a neural network in pure isolation. They measure the model operating inside a harness.
A harness. Like the surrounding software architecture.
Exactly. It's the infrastructure that executes the model's actions, manages its memory state, and feeds it context. And the default harness for the ARC benchmark was quietly tripling the model in two major ways.
How so?
First, it was wiping the model's private reasoning after every single move.
That is like forcing a chess grandmaster to play a tournament, but giving them amnesia after every single turn.
That is the perfect analogy.
They look at the board, figure out a brilliant 10-move strategy, move their knight, and instantly forget everything they just planned. They have to stare at the board and deduce their entire strategy from scratch every time they touch a piece.
It is a massive handicap. And the second issue was the context window. As the game progressed, the model's memory buffer would fill up with data. So to save space, the harness used a rolling truncation window.
Meaning it just deleted the old stuff.
Exactly. It simply chopped off the oldest actions and deleted them so the model could no longer see them. OpenAI realized the benchmark wasn't testing reasoning at all. It was testing bad memory management.
Wow.
So they switched the harness to use their own responses API, which utilizes a feature called compaction.
Okay, let's pause there because compaction is a term that gets thrown around a lot. What is it mechanically doing?
Instead of just deleting the oldest tokens when the memory gets full, compaction takes those previous reasoning steps and semantically compresses them.
Semantically compresses them.
Yeah, it squashes the textual reasoning down into a dense vector representation. The model retains the underlying meaning and strategic insights of its past actions without taking up massive amounts of raw text space in its active memory.
So it compresses the file, essentially.
Like, pretty much.
And just by changing that harness architecture to allow for compaction and persistent reasoning, the model's score skyrocketed. It went from 7.8% to 38.3%.
Almost tripled.
And shockingly, it used 6 times fewer output tokens to do it because it didn't have to keep re-explaining the rules of the game to itself every single turn.
Right, it actually remembered what it was doing.
But if changing a single API setting triples a benchmark score, does that render our industry leaderboards completely meaningless? Like, are we actually measuring the intelligence of the AI, or are we just measuring which lab wrote the most optimized harness?
Honestly, we are largely measuring the harness. The neural network's weights might contain immense latent capability, but if the surrounding software infrastructure bottlenecks the memory or truncates the reasoning, the model appears foolish.
Which is terrifying when you think about deployment.
It proves that orchestration matters just as much as raw intelligence.
And if we can't fully trust standard benchmarks at face value, and if we are spending 85% of our time verifying AI-generated code because the real world is messy, we need a better way to guarantee safety.
We really do.
Which brings us to the most rigorous and arguably the most painful method of software testing in existence. The Pragmatic Engineer newsletter just featured a deep dive with Hillel Wayne, a consultant who specializes in formal methods.
Yeah. Formal methods take us out of the realm of standard unit testing and into the realm of mathematical proofs.
Mathematical proofs for code.
Exactly. Wayne focuses on a specification language called TLA plus AH, which was created by the Turing Award-winning computer scientist Leslie Lamport. Standard software testing involves writing a script to see if a specific function returns the correct answer. TLA plus doesn't do that.
What does it do?
It maps out the entire universe of your software. It forces you to mathematically define every single possible state the system can transition into.
Every single state?
Every single one. And then it systematically proves whether the system can ever reach a state you define as fatal.
They give a terrifying example of why this is necessary. Amazon used TLA Plus on their AWS infrastructure, and they found a bug so incredibly complex that it took a 35-step error trace to replicate.
Yeah, 35 steps.
Meaning 35 very specific, localized failures had to happen in the exact right sequence for the system to crash. A human writing standard unit tests would never ever dream up that 35-step scenario.
Because humans cannot hold that level of state space explosion in their heads. It's just too much.
Wayne is particularly focused on finding time of check versus time of use bugs.
Oh, those are the worst. For anyone unfamiliar with this is like checking your bank app and seeing you have $100. Right. You initiate a transfer to pay friend $100, but in the 50 milliseconds between the system checking your balance and actually executing the transfer, a monthly subscription auto-renews and deducts $10.
It's a classic race condition.
Exactly. The system already approved your transfer based on the old check, so it pushes it through, and suddenly your account is overdrawn. TLA Plus is designed to find those exact temporal collision states. It finds the bugs that happen in the margins of time.
So here's my question. If TLA Plus is this ultimate superpower for catching catastrophic bugs, and AI is now capable of writing 500,000 lines of Rust in a week, why can't we just unleash an army of agents to write all the TLA Plus formal specifications for us?
Well, because writing the specification requires mapping reality, and reality is profoundly messy. Wayne argues that AI will not make formal verification mainstream because defining the boundaries of the real world mathematically is a uniquely human bottleneck.
How so? Can you give an example?
Sure. He gives a seemingly simple example.
Right.
Write a specification to find a file in a directory with the most lines of text.
Sounds easy enough.
To do that mathematically, you have to define what a file actually is. Are we only looking at ASCII text or UTF-8 encoding? What if a file has restricted permissions and the system can't read it?
Oh, I see.
What if the file is actually a symbolic link pointing to an entirely different server? The mathematics of TLA Plus require you to explicitly define every single edge case in the universe you are modeling.
So the AI can write the syntax of the language, but it doesn't know the business logic or the physical constraints of the server farm, unless a human spends months manually defining those parameters.
Exactly. The domain knowledge remains the bottleneck. The AI doesn't know what it doesn't know about your specific server setup.
So what's the solution then?
Instead of trying to formally prove every line of code, Wayne advocates for a middle ground called property-based testing.
Property-based testing.
Right. Instead of mapping the entire universe, you define the core, unshakable properties of your system, like a user's balance can never fall below 0.
Okay, that's much simpler.
And then you use automated tools to throw millions of randomized inputs at the system to see if you can violate that single property. It is a lightweight, formal method that provides robust security without the agonizing pain of defining the entire world mathematically.
We are constantly looking for these practical middle grounds right now. We're using AI to orchestrate physical robots, write low-level code, and generate randomized testing properties. All of this orchestration is massively changing the day-to-day reality of the human sitting at the desk.
It really is.
And that brings us to our take of the week. We need to talk about what this means for your career.
Yeah, this is the part people really need to pay attention to. OpenAI's Economic Research Division just released a report called Work at the Frontier. They analyzed 800,000 ChatGPT messages to understand how AI is actually being deployed in the wild.
800,000 messages. That is a massive sample size.
It is. And they uncovered a massive trend they're calling task crossover.
Task crossover, meaning people are using AI to do things that are decidedly not in their job description.
Emphatically, yes. When the researchers filtered out generic tasks, like summarizing a meeting or writing a polite email, they found that a staggering 43.5% of occupation-specific queries were people doing tasks entirely outside of their official domain.
Wait, almost half of the specialized work people are doing with AI belongs to someone else's department.
Yep. The breakdown by role is fascinating. For customer experience workers, 77% of their AI tasks belong to other roles.
That is wild.
Designers were pulling 35.2% of their tasks from outside their domain, and marketing tasks were the most viral. They spread further across all other departments than any other skill.
Wow. So what exactly are they borrowing?
When you look at the specific tasks being borrowed, tech troubleshooting and financial calculations were in the top 3 for almost every single occupation.
That makes total sense. In the past, if a marketer needed a complex data pull, they submitted a ticket to IT and waited 2 weeks.
Right. They were blocked by another department.
Now they are just using an AI agent to write the SQL query and parse the data themselves.
Exactly. This is especially prevalent in small businesses, where companies simply don't have the budget to hire a dedicated specialist for every vertical. The worker closest to the problem is using AI to solve it locally.
The AI is acting as a universal translator for skills, putting capabilities that used to require a computer science degree within reach of everyone. But let's look at the logical conclusion of this. If a marketer can do their own data science, and a customer service rep can run their own financial risk analysis, are we watching the death of the specialist?
It's a real question.
Like, what does a modern company org chart even look like if everyone is just a generalist orchestrating AI agents?
Well, the org chart definitely flattens. If the AI is handling the raw implementation, writing the code, drafting the copy, calculating the math, the human's job shifts entirely to critical thinking, domain context, and verification.
Which goes right back to the building inspector analogy.
Exactly. You don't need to know the syntax of a financial model, but you absolutely must have the business acumen to look at the AI's output and know if the numbers actually make sense for your market. The premium shifts from knowing how to build the wall to knowing where the wall should go and whether it actually meets code.
Which perfectly ties together the narrative of this entire deep dive. We are all becoming building inspectors. Let's do a quick recap of the massive shifts we covered today. First, Google DeepMind is giving robots the spatial reasoning and temporal intelligence to identify moments and catch their own physical mistakes in real time with Gemini Robotics 2.
Second, the 11-day rewrite of the Bun runtime proves that generating code is now the easy part. The human effort has entirely shifted to orchestrating agents and verifying the outputs.
Third, we learned that an AI model is often constrained by its harness, as OpenAI demonstrated by drastically improving a benchmark score simply by allowing the model to compress and retain its own reasoning.
Fourth, because the real world is too messy for total mathematical proof, lightweight formal methods like property-based testing are becoming our best defense against AI hallucinations in critical infrastructure.
And finally, thanks to AI acting as a universal skill translator, task crossover means your official job description is likely already obsolete. If you found this deep dive useful and it helped you make sense of the noise this week, please do us a favor. Rate the show and leave a comment on Spotify or Apple Podcasts. It genuinely helps us continue bringing these insights.
And as we sign off, we want to leave you with one final thought to mull over.
Yeah. If AI tools are making advanced skills available to more people, essentially turning all of us into highly capable generalists who just orchestrate agents, what happens to the value of deep, hyper-specialized human craft? If anyone can generate a good enough answer, will true, ground-up human expertise become a highly sought-after luxury good? Or will it just become a bottleneck in an industry moving at the speed of compute?
It is definitely something to seriously consider the next time you use an AI to do someone else's job.
Until next week, keep orchestrating. Thanks for joining us on the AI Loop.